If you've ever seen something that was made on a 3D printer and wondered how it all works, this video will walk you through the basics. We're going to be taking a 3D design, saving it as an STL file, prepping it in our 3D printer software, then sending it to the 3D printer. For our example, let's take this auto brush invention that was created by a student in Tinkercad. We are going to export it as an STL file, and then we'll bring it into our 3D printing software and set it up so we can send it to the printer. So we're going to click the export button. I'm exporting everything in the design, and I want to export it as an STL file. Now I see that file downloaded. I am going to switch over to my Cura software, which we use for an Ultimaker 3D printer. And I'm going to bring in that STL file that we just saved. Before we send this to the printer, there are some settings that we can tweak that will either make our print faster or stronger, or just work a little bit better, or keep it from failing, depending on the shape and size of the object that we're printing. This is a pretty good example of a 3D printer friendly file because it has a flat bottom and it doesn't have anything that's hanging out with any support underneath it. So we actually don't have to change too much here, but I'll just show you the different settings that most 3D printers offer. The first setting is how thick we want each layer to be. So this is 0.2 millimeters for every single layer, and it's going to be printing from the bottom up. So every layer is going to be 0.2 millimeters. If we lowered this number, the print would take a lot longer because each layer would be thinner, so there would be more layers for the same size item. We don't really need to do that because we're not printing something with a super high level, super high detail. The next value is the infill percent. This is how much of the inside of your model you want to be solid plastic. If you went up to 100%, your model would print as a solid piece of plastic, which would take a really long time and kind of waste a lot of plastic. Most things don't need to be solid plastic. We're going to leave ours here, which looks like it's about 5%. So that will make a nice little support on the inside of our model to make it strong and make it print completely, but it won't use too much plastic and it won't make it take a long time. If we were printing something that had things that were hanging in the air without anything underneath them, we would want the printer to print support, but since this one pretty much supports itself, we can uncheck that box. And then adhesion is good, again, for a model that doesn't have a nice flat base. Since this one does, I'm going to take my chances and I'm not going to print the raft underneath it to hold it onto the build plate. At the end of this video, I will show you an example of a print that has both support and adhesion, so you can see what that looks like and why you might need it for different types of 3D printing projects. Once we're happy with our settings, we can click the slice button, and now the software is going to do all the calculations to make sure that we can send this to the 3D printer. As you can see, at this size, it's going to take about 16 minutes to 3D print this. I'm going to save this to a removable disk, and we will take it to the 3D printer. So now we've moved to our 3D printer. We've loaded up the file that we just prepared, and the 3D printer is going to warm up so it can start printing it. And what's going on here is it is heating the extruder up to about 400 plus degrees Fahrenheit, and that's what is going to melt our plastic filament so that it can go layer by layer. It's going to print. As it comes out, it's coming out as a liquid, and as soon as it hits the air, it's hardening back into solid plastic, and then the extruder can move up a little bit and it can do the next level on top of the one that it just did as it is hardening back to solid plastic. In real time, this would take almost 20 minutes to warm up and complete the print, so I'm going to speed it up a little bit so we can see it in a fraction of that time. As you can see, it's starting at the very bottom and it's going layer by layer. It's doing one thin layer of melted liquid plastic at a time, and then it moves up just a little bit and it does the next layer right on top. Here is another print that was printed, and we actually did use the base so that it would have something to stick to the build plate, and we also allowed it to print supports. This one is kind of a chair, so it needed those supports when it got up to the actual flat part of the chair. And as you can see, the base just comes right off, and so do those supports. And now those supports have all been removed, and you can see why we needed them. Without those supports, that when it got to the flat part, there would have been nothing for the filament to stick to while it comes out in its liquid form, and it would have gotten a weird droopy thing here, and it wouldn't have had this nice flat section to it like it's supposed to. And now that all the supports and the raft are off, this print is done and ready to display. I hope you enjoyed seeing a little bit of the process of going from a 3D model to a finished 3D print. Thanks for watching.